Assalamu alaikum and hello everyone. Can everyone hear me? Okay, now, so let's get started with our session. Today, we are focusing on P1, and I'll be conducting 5 different sessions. Naturally, it will be of P1, S1, M1, P3, and S2. Now, what is the focus? The focus is I'll be going over the examiner report, even more important than the paper itself. That is the examiner report. And we will focus on the don'ts and what needs to be done. So, the do's and the don'ts, we have to focus on that. I'll be focusing on the 2025 paper, whether it's variant 1.1, 1.2, 1.3, and yes, there is also a new and a fourth variant that is 1.5. So they just skipped a number, 1.4, and now it's directly to 1.5. So now let's look at the paper. And the paper starts from here. And let me just do some adjustment. All good. So now if I'm looking at this particular paper, and I'll be looking at selected questions. By the way, you will be able to find the complete solution for all 4 variants on my YouTube channel so that you can comfortably watch it later. Yes, today is Friday, and then we have Saturday, we have Sunday, and Monday, 6th October. That is your P1 paper. And then 8th October, which is a Wednesday, that is your S1 paper. And in S1, most probably, most likely today, I'll be putting in the fourth video. So all 4 variants of S1 will be there. All 4 variants of P1 will be there. So don't you worry about that. Let's focus on some of the basic things. That is which people skip. And because of that, they lose marks. The most important thing is this. You should use a calculator where appropriate. That means it's not always appropriate to use a calculator because from the perspective of P1, the examiner pays a lot of emphasis on exact form. Now, what exactly is the exact form? Writing in fractions is exact. Writing in third form is exact. Writing in terms of pi is exact. So for P1 level, this is exact. Now, what about our friend decimal? So if the answer is inexact, then only worry about accuracy. Now, a lot of people, they just have a habit of going to the calculator all of a sudden without even thinking, without even writing down the steps. People, you're not doing a great thing. You are basically reducing your chances of getting an A. So one of the things that we need to focus is if answer is inexact, then worry about accuracy. The normal rule, what is the normal rule? The normal rule is give non-exact numerical answers correct to 3 significant figures. That means we should work in at least 4 SF. If you want to work in 5 SF, there is no harm, but at least 4 SF. Or what is the other thing? That is this thing, or 1 decimal place for angle in degrees. That means work in 2 decimal places. And what about angle in radians? So angle in radians, they also fall into this category of 3 significant figure. So the rule is 1 level up, at least 1 level up. If they are asking from the perspective of three significant figure. So for 3SF, work in 4SF. If they are asking to one decimal place, work in two decimal place. And remember the keyword, that is at least. If you want to work in 5SF, no harm. If you want to work in 3DP, no harm. So now this is very, very important. And the statement is not yet complete. What does it say? Let me change into black marker. And over here, what else does it say? Unless a different level of accuracy is specified in the question. If in that particular question, they are asking us give the answer correct to 5DP. If in a particular question, they might say that. Therefore, work in at least what? One level up. That is 60. So now this is something very important. And there is one other thing that you need to focus on. That is, you must show all necessary working clearly. No marks will be given for unsupported answer from a calculator. So now let me show you some working, and our focus is following instructions. No matter how good you are, if you don't follow instructions, then it's useless. Now, if I look at this particular question, this is about trigonometry. There is a sign over here. There is a sign over here. Angle lies between negative 180 to positive 180. That means you have to go anti-clockwise from 0 till positive 180. So that's the first and the second quadrant. And then 0 to negative 180, you have to go clockwise. Clockwise angles are negative. So first you will come across fourth quadrant and then the third quadrant. So now over here, also, if you want, it's not a must. If you want, let sine theta be denoted by the symbol S. So for simplicity, I have written it like this. I have written it like this. And then multiply throughout. Don't forget anything. The basics of algebra, that is the heart and soul of A-level maths. Without algebra, we stand nowhere. So this is 6 sine square. This 1 is multiplied with S. 2 remains as it is. We get this quadratic. In most cases, this is middle term factorization. So this is the symbol that I use. That is middle term breaking. The proper name is middle term factorization, the heart and soul of algebra. So now we factorize. We get two values of S. One is negative half, one is 2/3. Remember, the maximum value of sine is 1. The minimum value of sine is negative 1. The same goes for cos. But for tangent, it is infinity till negative infinity. That is tangent of theta. Well, anyway, let's focus on this. So now if sine is negative, basically it's the third and the fourth quadrant. So we are focusing on this. If sine is positive, that's first and second quadrant. We are focusing on the 0 till 180, and this one is 0 till negative 180. So now let's focus on the normal thing that we come across. Sine beta. Beta is the symbol that I use for a basic angle. I can even use alpha. That's your choice. Beta comes out to be 4181. This is 2dp. In the first quadrant, theta is basic angle. Second quadrant, 180 minus basic angle. So far, so good. Over here, the basic angle is 30. It's always calculated with a positive ratio. And then mark 30 over here, mark 30 over here. And now you have to go in this manner. If you go anti-clockwise, that's 210. But we have to go clockwise, which is negative 150. And if you go anti-clockwise, this is 330. Go clockwise, that is negative 30. So the smallest one is negative 150, negative 30, 41.8, 138.2. And over here, I have written the logic. How do you convert from anti-clockwise to clockwise? Just do the subtraction. Change anti-clockwise to clockwise, but then in the end, clockwise is written with a negative sign. So that is the first question that I wanted to focus on. Let me move ahead And let me focus on this particular question. That is about a geometric progression. The third term of a GP, as we call it, is 18. And the sum of the first three terms is 26. It is given that the common ratio is negative. That means the examiner is well aware that you might be ending with a positive sign also, so discard it. So remember the word discard. Any value that you are discarding it, better justify it. So the third term, that is AR power 2, is 18. Therefore, if I make A the subject, that is 18 over R square. And then I'm adding individually the first three terms. Now, someone can ask me this question, sir, why haven't you used the formula? Because in the formula, it would be A1 minus R cube over 1 minus R. Of course, we can also write R cube minus 1, R minus 1. That's not the issue, but this is the issue, the cubic thing. I don't want to get boggled down by a cubic sign because cubic is not part of the syllabus of P1. So therefore, it's wiser. Wisdom calls for it. That is, add up the terms individually. Again, I took A common out and we have this thing. So this is equation 1. This is equation 2. Now take this thing and place it in place of A. Cross multiply. And what are you seeing once again? What does MTF stands for? Middle term factorization. Again, you are getting two values. Yes, you are getting a positive. Discard. Why are you discarding it? Because the common ratio is negative. R is negative 3/4. What are they asking? They're asking, give your answer correct to 3SF. They're asking for the 10th term for 5 marks. So first of all, A is 18 over R square. Find A. And then move on this side. T10, AR power 9. Negative 3/4 raised to power of 9. You can work in decimals because they're asking in decimals. Otherwise, I would have worked in exact form. So now over here, how many significant figures? Now remember, these zeros are insignificant. You should know your O levels. You should know your IGCSE basic maths. And then you multiply right in 5SF. This is not 4SF. This is 5SF. Let me correct myself. So this is 5SF. And then the final answer, 3SF. And then over here in the same question, now they are focusing on exact value. Find the exact value of the sum to infinity. That is the formula. Plug in the value, play with fractions. The answer is 128 over 7. So now two questions are down. And this thing we have seen. This question, yes, it's a nice one. I'll be picking some questions from one variant, some from the other, and so on. So let me choose this question from here. So basically, if I make a table so that you have a pretty good idea what exactly are we working on. So first of all, we are focusing on the year 2025. And the session is May, June, because you are the one giving in November. And this is variant and the questions that I'm doing over here. So first of all, if I talk about variant 1-1, I think I have done, let me see which question have I done. Question number 1, that's trigonometry. Question number 3, that's GP. So this one, let me mark this as a favorite, not this one, this one. So question number 1, that is trigonometry. And question number 3, that is GP. And question number 4, that is area under graph, that is integration. Okay, so now I'm focusing on these ones. So 1 is done, 2 is done, and this is the 1. So now I want you to first have a good look at it. First of all, the diagrams that you see, they are not drawn to scale. At the same time, they are not misleading. They won't be giving you false information. So don't you worry about that. The background knowledge that I need is that area under the curve, that means below x-axis, that will come out to be negative. So area exists. So therefore, discard the negative sign. It's just a thing that area below x-axis will come out to be negative. So always discard it. So now over here, one thing that people get carried away is that they look at the curve and now they are kind of in a hurry and they just integrate the curve between 0 and 16. So that is wrong. Okay, by the way, the x coordinate of the point of intersection of the curve and the line is 1 and 16 they have given us. So this is 1, this is 16. And instead of 1 and 16, they calculate from 0 to 16. So they get all this area. We don't need all this area. We need this much of area from here. So we need to find the area under the curve like this and then subtract from it the triangle. I want you people to have a look. When x is 1, y is negative 15. Now, this diagram is definitely not drawn to scale. Now, look at this. This is 16 and this much is 15. So it's definitely not drawn to scale. When x is 1, y is negative 15. I plugged in the line equation because that was easier. Area of triangle, half into base into height. The base is 15, height is 15. Base is 15, height is 15. Area under the curve between 1 and 16. Now, this is where I want you to focus. First of all, let me grab the highlighter. That is, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, because the power over here was 1. Okay, let me write in black color. And then simplify. So now I am simplifying it. So don't be in a hurry. 1 hour, 50 minutes. Believe me, that's a lot of time. Of course, I'm talking very slowly, so I'm not asking you to do at my pace. This is for the lecture purposes. For your pace, if you think very comfortably, do each step after thinking, you are all set. So this is integration, simplification, then plug in the value. So this is the upper limit, you plug, you plug. This is the lower limit, you plug and plug. And then you simplify it. Yes, you are getting a negative sign, discard 504. This is 225 over 2. The difference 391.5. This is exact, no rounding off. So let me write over here. No need to ROUNDOFF. No need to round off. Keep that in mind. So now I have done 3 questions. Let me do this one also. That is binomial, question 5. So let me go over here and let me write in red color. That is question number 5. That is of binomial. So let me do binomial also. And then from some other paper, I'll be doing some other questions. So where is the binomial? I think that's the one. No, that is quadratics, my bad. There is the binomial. Now it says, find the first 3 terms in ascending powers of x in the expansion of each of the following. Now, these are the 2 formulas that we use. Technically, we can say there is one formula. That one formula is, first of all, why do we call it a binomial? Just like a bicycle. A cycle, I think that's just a cycle. I hope you get the idea. That's a cycle with 2 wheels. That's a bicycle, binomial, an algebraic expression with 2 terms. And in P1, we are dealing with a positive power, a positive integer power and nothing else. A plus b raised to power of n, nc0, b raised to power of 0, nc1, b raised to power of 1. The power of b is on the rise, the power of n is on the decline. A special case, what if the first term is 1? That is the step. This one, this is the first expansion, 5c0. And this is negative px raised to power of 0, 2 raised to power of 5, 5c1, and so on. A binomial is pretty basics. People love it. People like it. People get it right. After simplification, you get this. This one belongs to this category. Because when the first term is 1, 1 raised to any power will be unaffected. So there is no need of writing these terms. So again, 3 terms over here, 3 terms over here. Now it says, given that the coefficient of x square in this expansion is 93, find the possible values of constant p. So coefficient of x square, how can you get a coefficient of x square? You take the constant, multiply with the constant. My bad. You take the constant, multiply with x squared. You take the x squared, multiply with this constant. You take the x, you take the x. So just play with the coefficients. So 32 into 3 over 2. 80, this 80p square into 1. This negative 80 into negative 2. Add it all up, simplify, equate it to 93. And once again, what do you see? You see middle term factorization once again, the heart and soul of algebra. And you get two values. They're asking for two possible values. Now, let me go over this one. This is simultaneous and quadratics. So technically, it's quadratics. So now question number 6. That is simultaneous and discriminant. Technically, they both fall under the category of quadratics. So let's have a look at this particular one. That's right over here. Now, the first part is pretty simple. I think you can read it. The equation of a curve is such and such. The equation of a line is this, where k and p are constants. So now, yes, I want to emphasize one thing. And that emphasis is that this paragraph right over here, this is applicable for part A. This is applicable for part B. The examiner cries about this. The examiner complains about this, that people think that this is only valid for part A and then they forget about part B. Oh, the question is incomplete. Where is the missing piece of the puzzle? This missing piece of the puzzle applies to part A, it applies to part B. Keep that in mind. Given that K is 2, P is 11. So plug in these values, 2 and 11. Find the coordinates of the points of intersection of the curve and the line. They're asking for coordinates. Your answer better be in terms of coordinates. So now this is one is linear, the other is non-linear. Y is already the subject. And there is only one insertion of Y. So that is why I substituted this. I solve this, again, middle term factorization. And then what are we getting? We are getting two values of x. Plug in y, you get two corresponding values of y. Expect the unexpected. Life is not fair. Life is not just about integers. Fractions are part of life. So the x coordinate, the y coordinate, the x coordinate, the y coordinate coordinates both x and y. So let me write a small s over here. Coordinates of points of intersection. So plural coordinates both x and y, points 1 point, 2 point. That's how this is done. The next one, given instead, what does that mean? That means the values that you used over here, they are no longer valid. Yes, this is valid. So given instead that P is 4, K is unknown because we have to find the inequality for K. It says find the set of values of K. That means inequality. So set of values of K means inequality. Whether they say set of values of K or they say range of values of K, it means the same thing. So the word set and the word range, they mean the same thing. That means inequality, whether this or this. So now do not intersect. That means b square minus 4ac is less than 0. But first, you need to make a single equation. That single equation could be in terms of x, it could be in terms of y, doesn't make a difference. Again, there is one insertion of y, so therefore I plug in y. Again, you simplify. You have the x square coefficients, you have the x coefficient, you have the constant, write it out separately. Show comparing coefficient, show all working. B square minus 4ac is less than 0. Line do not intersect the curve. Write down the condition. You get a quadratic inequality. For quadratic inequality, sketch is a must. So there is no compromise on the sketch. Sketch is a must. Okay. So there is no shortcut. That's the way that I've taught. So now you factorize again, middle term factorization. And then you have this thing. You mark down the roots. K plus 4 equals to 0. K is negative 4. 9k minus 4 equals to 0. K is 4 over 9. Mark down the roots. Less than 0 means region below x-axis. Since this is one single region, one single answer, one single inequality, k has to lie between these two values in order for the y values to be negative. That's what it means. These are y values. They want to be negative. For which values of x will they be negative? Between these two. If the question was about greater, two separate region, two separate answer, k greater than 4 over 9, comma, k lesser than negative 4. So now I have focused on this one also. Circle, yes, this was a nice question. So question number 8, let me focus on this also. So basically, I might be focusing on two papers. And then, of course, on my channel, there are other papers also. So you can comfortably have a look because I'll be reading the examiner report also. So now this is circle equation. Let me focus on this particular one. So let's go over here. Where is the circle equation? That's right over here. Now, let me just add a page so that you have clarity of thinking. And let me just shuffle them up like this and like this. Okay. So now let's first read the question. It's for 8 marks. Just look at the what you call magnitude, the absolute value of this particular question, 8 marks. 8 marks out of 75. That is a lot. The circle with equation intersects the line at P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q and the line x is equals to negative 2. Now there are a lot of things over here. The first thing, let me first jot down. The solution is also already there. Let me jot down what exactly are we looking for. So first thing first, we have to do the conversion, the general form to the completed square form. That is the first step. Why? Because we need the center HK of the circle. The second thing, we have to apply the property that radius is perpendicular to tangent at the point of contact. And we know that if two lines are perpendicular, the gradient multiplied to give you -1. That is the knowledge that's used. We have to use coordinate geometry and we have to find equation of line. We might have to find point of intersection. That is about simultaneous equation. And last but not the least, we have to use area of triangle by drawing a diagram, and then we have to work it out and find the solution. So basically, let me remove this thing. So area of triangle will be based on a diagram. So now once you have decided the strategy, so I believe in forming the strategy first. So strategy is everything. Now let's look at the working. The first step, step 1, you write x squared with x, you write y squared with y, you transfer 27 to the other side. With the x's, first add, then subtract square of half the coefficient of x. So coefficient of x is -6, half of that is -3. First add, then subtract square of half the coefficient of x. Apply the same methodology with y. Coefficient of y is 10. First add, then subtract square of half the coefficient of y. Rewrite these three terms as a perfect square. That is the expanded form of this one. Rewrite these three terms as a perfect square. Transfer this to the other side. Transfer this to the other side. That becomes 61. This is x minus 3 whole square, y plus 5 whole square is 61. That is the gold standard. For quadratics, y is equals to a x minus h, a x minus h whole square plus k. That is the gold standard for quadratic. You get the turning point from here. You get the shape from here. Over here for the circle, that is the gold standard. Negative h is negative 3, h is 3. Negative k is positive 5, k is negative 5. 3 minus 5 is center of the circle. Radius was not needed over here. Otherwise, r square is 61. R is square root of 60. Step 2. The line x is equals to negative 2. So now when x is equals to negative 2, what are the y coordinates? So you can either plug in this one, no issue. I plugged in this one. I comfortably took the square root plus minus. I get two values of y, such and such. One is negative 11, the other one is positive 1. And over here, the center C is there. What is this working all about? Can you guess? That is the center of the circle. There is the point P. And let me show you this diagram. So now this diagram is there. And let me just do one thing. If I can copy this diagram, because sometimes there is an issue with copying. So no, not the color, my bad. Okay, let's hope it works over here. No, for some reason it doesn't work. So let me just remove this page like this. Okay. So now let's focus on this. So now what I'm trying to do is that I have drawn a realistic diagram. This is the center, C. And let me write C over here. And then one of the point of intersection of the circle and this line, that is x is equals to negative 2. We have P, we have Q. P is negative 2, negative 11. They did not mention which one is P, which one is Q, so it doesn't make a difference. P is negative 2, negative 11. Q is negative 2 and 1. So this is down below, this is up. So this is down below P, negative 2, negative 11. Let me write it. Negative 2, negative 11. And Q is, let me just erase this. Q is negative 2 and 1. So that is P, Q, and C. Now, what are they asking? They are asking area of triangle formed by the tangents to the circle at P and Q. There is a circle. There will be two tangents. They will be meeting over here. And this is the triangle that's formed. So conceptualize. This question is for A star people or maximum A people. Not everyone will be able to do it. So now what I've done is that I have the center, I have P, I find the gradient of PC. Let me write over here. This is gradient of PC. I have C, I have Q, I find the gradient of CQ. Now in green color, I am drawing a tangent at P. So the gradient will be negative reciprocal. Similarly, in red color, I'm drawing a tangent at Q, again, negative reciprocal. So now we have P, negative 2, negative 11. So let me write over here. P is negative 2, negative 11. And over here, Q is over here. That is negative 2 and 1. Now see everything in the right perspective. Now you have the gradient of the tangent. You have the point. Find the equation. Gradient of the tangent, the point, find this equation. The two tangents meet at R simultaneously at R, therefore solve simultaneously. I have labeled this as R because there was P, there was Q. So let me label this as R. Now you solve it simultaneously. You find the value of X and you find the value of Y. Expect the unexpected. Expect similar answers like this. Once you get the hang of it, so now you can either use that formula half x1, x2, x3, x1, y1, y2, y3, y1, and then you can start from any point and go anti-clockwise. So let's say you start from this point and then you go anti-clockwise. But what I believe in is concepts. So this is 1, this is negative 11, this is 12 units. That's a base. And from this point, the x coordinate of this point is -2. This point is -46 over 5. So the difference between 46 over 5 and -2 is 36 over 5. So let me say this point, let me mark this as M. So if I label 1 and -11, -10, so this is -5. This is -2, -5. So now basically I'm looking at this height. This is the height. This whole thing is the base. So just ignore the negative sign, ignore -2, ignore for -46 over 5. The difference between the two is 36 over 5. Half into base into height, you get this answer. The answer is in the exact form. So far, so good. Let me skip. No, this one was a good one. And of course, this was also good. So let me focus on 10, that is functions. Let me focus on 9. So let me go back up here. Let me focus on 9, that is circular measure. Let me focus on 10, that is functions. So basically in this paper, that is variant 1, I have focused on 1, 3, 4. I missed out 2. 5 was there, 6 was there, I missed out 7. 8 was there, 9 was there, 10 was there. So except for 2, 3, I have almost done the whole paper. So now let me focus on, or let me skip circular measure. Hold for a second. Let me skip circular measure. Let me just focus on functions. So let me focus on function and then I'll move to a new paper. Don't worry about that. So that is this one over here. Let me again add a page. And let me again add a page. Let me change the order, something like this. And let me pull it all the way up. So now over here, this is all good, all clear. I was just looking at one thing. I think I wrote it over here. Okay, so that was just a blank page. So now over here, let's focus on this. I want you to read this thing first. The functions f and g are defined by such and such. So now fx is root x. Now people, I have a very less habit of reading the comments in YouTube. Someone wrote, circular measure is difficult for me. Yes, people, so you can watch the basic videos or just focus on 2025 and you can watch the other videos also. I'm not skipping it. I'll be doing a circular measure question from the next paper. So I'm basically focusing on every single topic to the best of my ability. The functions f and g are defined by fx as root x, gx as such and such, for x is greater than or equal to this thing, and so on. Describe fully a sequence of transformation. So you have to describe fully a sequence of transformation which transform fx onto gx. You should make clear the order in which the transformation is applied for 5 marks. That is the first thing. The second thing, the diagram shows the graph of y is equals to gx. On the diagram, sketch the graph of y is equals to g inverse together with any relevant mirror line. The relevant mirror line is y is equals to x. That is the mirror line, and you just flip it. So the first two parts are easy. The first part is slightly tricky, but overall, it's not that bad. Find an expression for G inverse. So we would write let y is equals to gx. Therefore, G inverse y is equals to x. And then we would find the expression. State the range of G inverse. Range of G inverse is domain of G. Very basic. The function h is defined by such and such. Hx is given a straight line. Find the value of G inverse h4. This is composite. And explain why the composite cannot be formed. So let me first, I'll just do it at the end. This 1 mark that people find difficult. So now let's look at this thing. So now it says the function f and g are such and such. So now how are we working along? So fx is root x, and then gx is this thing. So inside out, basically +2. So first of all, root x is becoming root x plus 2. What is happening? It's a horizontal shift, or you can use the word translation. When we use the word translation, we can say translation parallel to x-axis, or you can say along x-axis. And don't forget to give the translation vector. That is a must. Plus 2 means it's moving 2 units to the left. So this is 2 units to the left. Write it, and of course also give the translation vector. Then this 3 comes in. So this 3 over here, that comes in. What is happening? It is a stretch parallel to y-axis. Scale factor is 3. And what is the third thing? The third thing is this -5, vertical translation or vertical shift. You can also say parallel to y-axis. And the graph moves 5 units down. And then don't forget to give the translation vector. This one was very easy. Make sure it looks realistic. It's a test of your artistic ability. So basically, you just have to make sure that if this is a line of symmetry and you cut along this line, you fold along this line, then this thing should overlap. I have just labeled a point for myself. Reflection in y is equals to x. A point AB becomes BA. If this point is m comma 0, this is 0 comma m. Two things are done. The expression for G inverse x. Let y is equals to gx, G inverse y is equals to x. Instead of gx, write y and square it. And then x is G inverse y. We have a habit of writing everything in terms of x, so just change the variable. That is pretty easy. State the range of G inverse. Domain of Gx is the range of G inverse. Write it in the inequality form. Hx is there, G inverse of h of 4. First evaluate. They're not asking for the expression. Just evaluate h of 4. That comes out to be 2. So now this h of 4, hold for a second, this h of 4 is 2. So now in place of h of 4, we are writing 2. Now plug in this 2 in G inverse, simplify, you get 31 over 9. Now this is conceptual. Have a good look at this. Explain why the composite function Hg inverse cannot be formed. Now, first of all, we have to write the general statement. It's only for 1 mark, but they have used the word explain. So you have to explain. 1 mark is probably because of the fact that since it's a difficult question, not everyone gets this. Not everyone can teach this. So that is why the examiner wants you to have a very good advantage. Now the rule is the composite function. In order for a composite to be formed, whatever is coming out of G inverse should be going inside H. Hg inverse will exist if the output of G inverse, that is the range, that is this value, x is greater than or equal to -2. The output of G inverse is, let me write over here, this is the output. G inverse x is greater than or equal to -2. Just focus on this thing. Just focus on this inequality, greater than or equal to -2. That should be a subset of domain of Hx. Now, why is this so? Let me try to explain this, because this is not a regular class. So I assume that you have already studied this. And that thing is, when we say Hg inverse, so this is the order. Hg inverse x. That means first x will go inside G inverse, and whatever is the output, that will go in place of x. So the output of G inverse becomes the input of Hx. So output of G inverse is the range of G inverse. Input of Hx, that is the domain of Hx. In order for it to exist, this has to be a subset of this. Now over here, this is greater than or equal to -2. That is a bigger number line. This is greater than or equal to 0. That is a shorter number line. How can you fit a big thing inside a small one? You cannot. Since x is greater than or equal to -2, is not a subset. It's not contained within this thing. Therefore, the inverse does not exist. That's the same thing written over here. So now, people, when you come across a difficult question, you don't always have to try it out and get stubborn with this. So never be stubborn. So never be stubborn with a particular question. 1 mark, skip it. In the end, have a good luck. Now, based upon public request, let me go to the circular measure question because someone has requested it. And let me write over there, this thing is favorite. And this is question number 9. So red marker, question number 9. So we are doing circular measure also from this paper. So now let me go over this, and that's right over here. So now let's look at this question. So now it says the diagram shows a sector ABC of a circle with center A. And I feel that this one paper has a lot of things in it. And I would be focusing on the examiner report after this question, because unless and until you are very thorough with examiner report, then it's a big issue. So there is a WhatsApp group that is formed. So I don't know how many people are part of that WhatsApp group. So if you're part of that WhatsApp group, or if you can just send me some info on Instagram. So any other links that you need it, I'll be able to provide it to you. So I think that is my Instagram handle. And you can just take a screenshot or the QR code thing. So now over here, if I'm focusing on this one, so what is it saying? It says the diagram shows the sector ABC of a circle with center A and radius R. Center A, radius R, angle alpha. The angle is in radians. Yes, yes, yes. Very necessary. Radian and circular measure, inseparable. Make sure calculator is in radian mode. Make sure angle is in radians. The formula that you use, SSR theta, theta is in radians. Make sure this that you use, half r squared theta, theta is in radians. Make sure you use sine, cos, tan, or sine rule, cosine rule. Make sure your calculator is in the radian. So now, first of all, it says alpha lies between 0 and pi by 2. It's an acute angle. Now, the working was very nice. It is given that the area of the triangle is 4 centimeters square and the area of the sector is 8 alpha. So area of triangle, half AB sine C. And area of sector, half R square alpha. So area of triangle, that's a formula. Area of sector, that's a formula. Area of sector is 8 alpha. In other words, R comes out to be 4. So it seemed initially like it's two unknowns are there, but that's not the issue. You first find R. Now you plug the value of R over here. So half R square sine alpha, half 4 square sine alpha, 8 sine alpha, half into 4 square is 8. So let me write one more step over here, which I think I skipped. Okay. So now over here, this is 8 sine alpha is 4. Therefore, sine alpha is half. Alpha is 30 degrees in radians. It's pi by 6. Area of shaded region. You don't have to do the working all over again because area of sector is 8 alpha. Area of triangle is 4. All you need to do is to plug in pi by 6, and this answer is in the exact form. Did they say exact? Yes, they definitely said it. So now the person who asked me on YouTube in the comment section that, sir, please solve this. I hope he is happy now. Now the next one. It says it is given instead that the length of the chord BC is 1 over root 2, R over root 2. But the area of the triangle is still the same. Now this one was slightly tricky. Find the area of the shaded segment, give your answer correct to 3 significant figures. So the examiner balances between decimals and exact form. Because there are some people who are not so good with exact but good with decimals. There are some who are good with decimals but not so good with exact, or vice versa. So the examiner has to balance it. So now over here, this thing that we have the length of the chord and then applying cosine rule. And I find alpha, cos alpha is 3/4, cos inverse, work in four significant figure. So first thing first, you have this, you have this, you have this, find this using cosine. Now area is still 4. The area of triangle half r square sine alpha is this thing, so r is different. Alpha is different, r is different. Yes, the area was the same, but alpha and r are different. Area of sector, half r square alpha. Area of shaded region, sector minus triangle, that is this much, a very small answer. So now let me go to the exam report. And there is the exam report, and I would be focusing on different exam reports, all of P1. And let's do a little bit of coloring. So this is pure maths 1. This is variant 1-1. This is key message for this variant, which is variant 1-1. So this is May, June 2025 and variant 1. So now let me focus on the key messages. It says the question paper contains a statement in the rubric. On the front cover, no marks will be given for unsupported answer from a calculator. What does this mean? Let me start highlighting. Now it means the following. Clear working must be shown to justify solutions, particularly in syllabus items such as quadratic and trig equation. In the case of quadratic, it would be necessary to show factorization. Use the quadratic formula or completing the square as stated in the syllabus. Using calculators to solve equations and writing down only the solution. They are not stopping you from uh, using the calculator. They are stopping you from only using a calculator. Is not sufficient for full marks to be awarded. It's also insufficient to quote only the formula. Candidates need to show values substituted into it. And then when factorizing, candidates should ensure that the factors always expand to give the coefficients. So make sure your middle term factorization is all good. Now, this is the heart and soul of this key message. And also over here, using a column vector to describe translation is the most effective approach as it allows candidates to be clear and concise, besides writing down the name. Okay. So now this is from variant 1-1, the one variant that you just studied. Let me go to the second one. Now this is the second one. That is over here. That is pure maths P1, variant 1-2, key message. So this is May, June 2025, variant 1-2. Now over here, this is something very strange that the examiner has to resort writing this. Candidates would benefit from more practice on basic algebraic techniques. The examiner wants you to focus on basic algebraic techniques. What are the 4 mistakes that the examiner observed? The first one, the use of quadratic formula to solve quadratic equation with only 2 terms and then making mistake with it. Let's say if I focus on the first one, so let me just make a box over here somewhere. And what the examiner is saying is this. Let's say if I have x squared minus 5 equals to 0. Therefore, x squared is 5. Therefore, x is plus minus root 5. Would you use a quadratic formula for this? Of course not. Let's say you have x squared plus 3x equals to 0. X common, x plus 3 equals to 0. Therefore, x is 0. Therefore, x is 3. Would you use a quadratic formula? The answer is no. The second thing, that is in purple color. That is the error of thinking this thing is this. It's not. So now let me use another box. And over here, let me write it. That is negative a negative b whole square. Negative a negative b whole square is negative 1 common. A plus b, the whole thing square. So the square applies on negative 1 also. Therefore, this is positive 1, a plus b whole square. This is the correct thing. So this is point number 2. This is point number 1. Got this? So this is an error that they are talking about. The error of thinking. Similarly, some people, they think this thing. The error of thinking minus a minus b whole square is this thing. I mean, this is strange. So that is why the examiner is saying this thing. That is basic algebraic techniques learned in O levels, learned in IGCSE should be very, very good. The fourth one, which is this thing. Let me use a blue marker. So now the error of thinking that 4.5 minus 12 is negative 7.5a. Now I'm very sure that some people are kind of confused. What is strange in this one? The strange thing is this is simply 12. This is not 12a. 4.5a minus 12a. Yes, this is equals to negative 7.5a. But 4.5a minus 12, you cannot move ahead. There is nothing can be done. So this is nothing can be done. Got the idea? So that is this thing. That is question number 4 over here. So now these are some of the things that the examiner is talking about. Let me move to the third one. What is happening in the third one? In the third one, Pure Maths 1, variant 1.3. Let me write over here. Let's see if there is anything special. So May, June 2025, variant 1.3. Over here, let me focus on this. Excuse me. Candidates' inability to perform basic algebra was responsible for them losing a considerable number of marks. Centers should provide more practice in dealing with algebraic solution rather than numerical ones that can be evaluated on calculator. Golden words. That is what I do in my class. That is work with algebraic solution, work with what you call symbols, rather than working with numerical ones which can be evaluated on the calculator. Improve your algebra. Many candidates did not understand the need to preserve extra places of decimals in the working in order to obtain answers of the required accuracy. Already talked about it. Yes, one other thing. Uh, Presentation was mostly good, although some answers still seem to be written in pencil and then overwritten with ink. Never ever do this. This practice produces a very unclear image, which is difficult to mark on screen. Centers should strongly advise not to do this. So that's from variant 1.3. And what's in variant 1.4? So now in variant 1.4, that is this thing, key message. And that is the purple one. That is Pure Maths 1. And let me write over here, this is May, June 2025, variant 1.5. Let's read the special stuff. Let me grab a highlighter first. Centers are reminded the candidates need to show full working to justify the answer. This is essential in questions such as 10b. That was a full algebra question, where the final result is given. Often in these cases, let me just show you what is 10b. Hold for a second. Let me go over here. And that is this paper. And over here, 10b was this thing. That was this circle question. This is variant 1.5. Make sure to watch this particular paper, a variant 1.5. This was a circle question. And I have done this algebra. Look at the magnitude of this algebra. A lot of terms are there. I have done it in two ways in terms of X, in terms of Y. Of course, you can go to the channel and watch it later. Just I was pointing out what is the examiner referring to. Examiner is referring to 10B where the final result is given. That means if the answer is given, show that. Then you have to show all the algebra. Often in cases, working lead to final answer is omitted and method marks lost. Then it says a key strength in high scoring scripts is thorough working, the way that I've taught you. Substitutions and formulae shown clearly and the solution to the equations shown fully. Where there is evidence, a calculator equation solver or calculator definite integration function has been used, full marks will not be awarded. And then later on, it says candidates should be encouraged to sketch functions, graphs, and coordinate grids, where these will be helpful in problem solving. So I think that's about it from my side. And I hope you enjoyed the session. And we are all set for the P1 exam. Again, let me emphasize it, 2025, all four variants. The videos are there on my channel, which is Mathematics with Shahab Yaqub. So you can check them out and other stuff is also there. Naturally, you have access to my lectures on the Alt channel. So people, wish you best of luck. And those who are part of Alt Academy, I would be meeting them on the WhatsApp group. Those who are part of my college, that is Credo College, so I'll also be meeting on the WhatsApp group. Take care, everyone.